Bonjour. Welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I am the teacher, Bronwyn Slate. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Expressview channel 972. You are always welcome to just join me live through Zoom. There's a link that's available both from me, your teacher, and also your DEC. Our classes are scheduled from Monday through Thursday, 2 until 3 in the afternoon, and we are in our 4th week of our 9-week course. You should be starting to think about submitting work soon. So a reminder that the support questions, the ones with the pencil icon, are not for marking. You decide which ones and how many to do. If you're understanding a concept, feel free to skip questions. You don't have to do them just because they're there. However, if you want more practice, let me know and I can send you more practice. The answers are in the back of your booklets, so please check your work. This way you know if you're on the right track or if you're struggling with a concept, it can help guide you. Mistakes sometimes are in the back of the book. I think I've caught them all, but if not, let me know if anything doesn't line up and we can make corrections. The key questions, the ones with the key icon, are the ones to submit for marking. So please do all of these questions. I will be marking them all, so do them all. And show all of your work, your steps, and your thinking. This way, I can understand what it is that you understand. And if you are making any mistakes, I have a better chance of figuring that out so I can help you. And also, I only take off part marks if you're making errors. If you still get parts that you still have parts of it right. So it's to your benefit to show me everything you're doing. So how do you actually submit your work for marking? Well, there's 3 methods. The first is to send your work and send it scan your work and send it electronically. You can scan your work if you have a device. If you have an Apple device, you can use the Notes app. And if you have an Android device, you can use the Google Drive app. These are free apps that generally come with these devices, but are really easy to download if you don't have them. And basically, it's pretty much a point and click scanning option. If you would like some tutorial to follow along on my YouTube channel, there are tech tutorials that are there that can walk you through how to use these apps to scan your work. Then you can send it by email to studentwork@nnec.on.ca and CC it to bronwyn.slate@nnec.on.ca. Or you can also send it to me through Facebook Messenger, where my name is bslatewaza. The second method is to drop your work off in Sioux Lookout. We have an outdoor mailbox at our 74 Front Street location. We're the bright red building next to the post office, and we have a small white mailbox next to our side entrance. So you can just put your work in there at any time and I'll get it back to you as soon as I can. The third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. If you'd like to connect with me through social media, both my Facebook profile and YouTube channel are under the name bslatewaza. You can friend me on Facebook or subscribe to my YouTube channel, and then you'll get updates every time I upload one of our videos. All of our radio Zoom classes are recorded and I upload them shortly after airing to YouTube. And so they're all there under a playlist called MBF3C. Also on my channel, there are short videos that explain common errors or confusing concepts. So if you're struggling with something, it could be a good place to go and get some more information into sort of a bite-sized piece that might help you with what it is that we are doing. Math is a really visual subject, so I strongly encourage you to connect with the videos. Either watching the Zoom live, even if you don't want to talk to me, that's fine, or watching the replays on YouTube on your own time are great options. If for some reason you don't have access to reliable internet and you'd still like to connect with the videos, Let me know and I'm happy to send you a copy of the recordings so you get the full experience. This really just will set you up for the most success if you can access both the audio and the visual. If you have any questions or concerns, please reach out and contact me. My email address is broadwood.slate. That's spelled BRONWYN.SLATE@nnec.on.ca. You can also reach me again on Facebook and we can chat through Messenger there. My name is B. Slate Wahsa. You can call me at the office at 807-737-1488. My extension is 2209, or you can call toll free at 1-800-667-3703. My office hours are Monday through Friday, 9 a.m. to 3 p.m., though I teach the last hour of my day. So if you want to connect with me directly, that's not a great time. All right, we are diving into lesson 8 today, which is looking in more detail at the compound interest formula. So our learning goals are that at the end of this lesson, you will be able to solve problems that find the principal in situations when interest is compounded, and you'll be able to solve problems where you must find the interest rate and the length of time when interest is compounded. You know you've met the learning goals because you can identify the given and missing information in the compound interest problems. You can use the nth root and guess and check methods to solve problems involving exponents, and you can solve problems when either the interest rate or time length are missing. So when will you use this in real life? Well, we are identifying the information we have and what we need to find. This is really important in life, not just in math class, but in life in general. When you are in situations, understanding what information, what tools you have, and what tools or information you still need is fundamental to problem solving and any sort of thing that interaction, any sort of life skill, basically. So this is the skill that we're working on. But first, let's of course do some mental math and activate our brains. I don't believe in Mad Math Minutes. They cause stress in students and don't teach any actual skills. Either you know your facts, you have them memorized, you can perform under pressure and speed, or you can't, and this doesn't improve it for you. So we don't focus on that as a tool. Instead, we develop strategies that we can use in various situations that set us up for success. All right, so today's question is 192 divided by 12, and we are going to share in groups. So I know that when I was learning to do division, we would draw our number of groups, and then we would share through with 1, 1, 1, 1 as we would go. So instead today we're going to share in groups, which we also kind of do if you're counting by like 5s or 10s. But I never really thought about it in terms of doing division. So I have 12 groups, and instead of going through and adding 1 in each of these groups until I get to 192, I'm going to go up in chunks. I'm going to go up in groups of numbers. So I'm going to share out I'm going to share out a bunch. So if I were to share out 10 in each group, I go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. So I've used up 120 of my 192. And so that was just a lot faster than going through and sharing out ones each time. So now that means I'm left with 72 still to share. So I can't do another groups of 10, but I could do groups of 5. So I'm at 120. So then I can say, well, 125, 130, 135, 140, 145, 150, 155, 160, 165, 170, 175, 180. So I've done now in my second step, I shared out, now I have a shared out a total of 180. So that means I'm only left with 12, which means all I have left is one for each group. So if I put in one in each of my groups, I've run out. I didn't count out loud this time, but I just put one in each group, which means that each group has 10 plus 5 plus 1, which is 16. So 192 divided by 12 is equal to 16, because each of my 12 groups has 16 things in it. So that's not a strategy that I use too often, but it still totally works. So you do what works best for you. All right, mine's on. What prior learning do we need to have? All right, I just wanted to run over what compound interest is again, as that's what we did in lesson 7. So compound interest is when interest is calculated on the principal and the earned interest. So you reinvest your interest after you earn it in order to earn money on the money you've already earned. So it has exponential growth, this orange curve. So this starting off slow and then getting faster and faster and faster as time goes up. Yes. You get free money from free money is how I like to think about it, because you're making money on the money that you're making. But it's really good for investments because you make free money on free money, but it's not helpful if you're borrowing money, because then you owe money on the money that the interest that you owe. So yeah, that's the overview of compound interest. We have this compound interest formula. If you have a really old booklet, you might have a different one. And in lesson 7, I go over how the two are related. But this is the one that we're going to be using in this lesson because it makes more sense and makes it easier to solve for the various pieces that we need. So we have A equals P, open a bracket, so times 1 plus R divided by N, close your bracket, to the exponent NT, so N times T, where remember A is your final amount in money, P is your principal invested, which is in dollars. So the amount of money that you start with, this is also true if you're borrowing money, is your principal. R is your interest rate expressed as a decimal. So percentages expressed as a decimal. N is the number of compounding periods per year. And T is your time in years. So remember, we also, this is, I have written down on my screen, A equals P times 1 plus I to the exponent NT. That is what we did in, that's what old booklets will have. But now this formula that I have is more commonly used. So then also a reminder that compounding frequency is how often we compound, how often we reinvest our money. And it is how many fit in a year is how we think of it. So if it's annually, we do 1 in a year. If it's semi-annually, 2 in a year. If it's quarterly, we do 4 in a year. If it's monthly, we do 12 in a year. If it's weekly, we do 52 in a year. If it's daily, it's 365 in a year. So those are really important words to know and remember. Okay, so then what are we doing new today? Well, let's dive into what we're doing, where now we're going to not just find A, the final amount, which is what we did in lesson 7, but be able to figure out if we're looking for the principal, the interest rate, or the time period. So we're going to be asking the questions, how much should I invest to earn a certain amount of money? So if you know that you want to earn $1 million in this law in 25 years at 12% interest rate, how much money do you need to invest? Or how long is it that you need to invest to earn a certain amount of money? So you want $100,000 and you know that you have $10,000 to invest. You know your interest rate is 5%. How long is it going to take you to actually earn that $100,000? Or what interest rate do you need to earn? So if a certain amount of money. So if you want to earn $20,000 and you've got $3,000 to invest, and you know that you need this $20,000 in 5 years, say, because you think that your car is going to die and you're going to need $20,000 for down payment or something. I don't know. I'm making something up. So then what percentage interest rate do you actually need that you should be shopping for in order to earn the amount of money that you need? So that's what we're focusing on today. So we're going to start with finding the principal in compound interest. So this is on page 16 of your IL booklet. And the real life context of this, so when you would actually do this, is when you want to find out how much money you should invest now in order to earn a certain amount over a set time period. So for example, a person wants to have $10,000 in 6 years. They can invest at 3% compounded semi-annually. What amount do they need to have now to make that happen? So it says compounded semi-annually, which makes us know that this is a compound interest question. Remember, simple interest is going to say simple interest in the question. Compound interest probably won't say compound interest, but it will say compound. It will tell you how often you're compounding. So then we know that we have to use this formula, A equals P times 1 plus R divided by N, also exponent N times T. And we list all of our variables so that we can figure out what it is that we know and what is it that we don't know. In lesson 7, we always were looking for the final amount. We were always looking for A, but this time that's not true. We have to figure out what it is that we know and what it is that we don't know we're looking for. So in this question, this person wants to have $10,000. So A is equal to $10,000. In 6 years, so our T is equal to 6. They can invest at 3%. So our rate is 3%, so 0.03. And it's compounded semi-annually. So that's twice a year. So N is equal to 2. Then they're asking, what amount do we invest now? So that's our principal. What do we need to start with? So the question isn't necessarily going to give it into the order that you list your variables. You can do it whatever way works for you in terms of writing your variables as you go, or always listing them in the same order. You do what makes sense for you. Then once we have all of our variables and what we're looking for, then we can put those numbers into our formula. So now we have 10,000 equals P times 1 plus 0.03 divided by 2, all to the exponent 2 times 6. So we're just replacing our variables. We're substituting them in with our values. Then we simplify that as much as we can. And now we're solving for P. So when we simplified, we had 10,000 is equal to P times 1.015 to the exponent 12. So to solve for P, we're dividing both sides by the amount that's multiplied by P. This is algebra. If you need to do some practicing with some algebra to solve for variables, check out my YouTube. There's some steps there to practice. There's some examples. There's lots of practice. If there's something you need to do, I'm not gonna go through the steps here too much, but this is something that you have to be able to use algebra. So P is actually equal to 10,000 divided by 1.015 to the exponent 12. So if we do that calculation, we get P is equal to $8,363.87. So therefore, this person needs to invest $8,363.87 now to have $10,000 in 6 years. Okay, so I just want you to, we're going to pause for a little bit. I want to interject something. Interject something. I just wanted to remind you what algebra with exponents, how this works. So in a situation where we have a variable with an exponent, so x to the 5th equals 32. This means x to the 5th is equal to x something times something times something times something times something, right? Something times itself 5 times. So 32 equals something times something times something times something times something. That something times itself 5 times. So when x to the 5th equals 32, what we're trying to figure out is what is that something times itself 5 times. So what we can do is we can take the 5th root of 32. This is the mathematical inverse operation of having an exponent, is you take the nth root. So for this example, we need to take the nth root. So that is going to give us, for this example, x equals 2, because 2 times 2 times 2 times 2 times 2 is equal to 32. So the square root of a number times the square root of a number is equal to that number. So we always use square root. It's used when we have 2 times the multiplication gives the original value. So because something squared is something times itself twice. So a square root is that 2 times that. That times itself twice gives you the original value. So cube root is a root sign with a little 3 on it. And that means that it's 3 times, you need to use it 3 times to get the original value. So the cubed root of a times the cubed root of a times the cubed root of a is equal to a. So the nth root is what we have for in general. So the nth root used n times in a multiplication gives the original value. So we can't, this is just general, so we can't write it down a certain number of n's because we don't know how many this is, but this is just the notation that we use when we are solving a variable with an exponent and we're trying to find the inverse operation. So for example, x cubed equals 125. So we would do the cube root of x cubed to cancel each other out. So just have x is equal to the cube root of 125. So to figure that out on your calculator, I don't expect you to know these things. To figure that out on your calculator, you have to find the nth root button. So it's often the second function of your exponent button. So it's often, which is usually x to the exponent y. So then it's going to look like this, where it has an x next to a root symbol. So if we look at Desmos, and we can see here on my calculator, my Desmos, a to the exponent b is our exponent button. And here right below it is the nth root. So I have a root symbol with a little n above it. I don't have to use a second function on my Desmos calculator, but many other calculators, you have to actually click function to get your second function to find it. Here, it's just one of the ones that we use frequently. So then how you put it in is that you put 3. So on Desmos, what you have to do is you have to put your nth root symbol in first, and then you can see my cursor is here on the root. So I put 3 there, and then I click underneath and I put 125, and that tells me that the answer is 5. You have to figure out what you have to do for your calculator. Do you put in your value underneath the root sign first and then press a button and then press the root? Do you do the root first and the button? You have to figure out your calculator. Is why it's so important to practice with your calculator so that you know what it is, how to use it. So then our answer is x equals 5. So another example, y to the exponent 8 is equal to 65,536. So 8th root of y to the 8 is equal to the 8th root of 65,536. So y equals to 4. So if we do 4 times itself 8 times, we'll get 65,536. And then finally, a to the exponent 15 is equal to 325. So we do the 15th root of a to the 15 is equal to the 15th root of 325, and we get a is equal to 1.4705. So these are often not whole numbers. They often you're going to end up with decimal. Remember, generally I suggest if you're writing down decimals to write down to 4 or 5 decimal places to get a pretty close result at the end. And that's how you use your nth root, which is what we're going to have to use to find our interest rate. Or no, yes. So if you are in your IEL booklet, if you're finding if you have the old version of the booklet and you're looking for for your interest rate, you're going to have to use the guess and check method. This is why I like using this formula better, because it breaks information down more and you don't have to guess as much. But if you're finding you're going to have to guess and check, just so you know. You don't need to be using you can use this formula because it's all the same, even if you have the old workbook. But just a reminder, if you're looking for guess and check is going to be your way to do it. All right, so for finding the interest rate R in compound interest, these are what we need to do. The real life context for this one would be that you want to find what interest rate you need to earn a goal amount when you have a set amount to invest now over a set time period. So you're looking for the interest rate that's best for you. So our example, a person wants to have $1,500 after 5 years. They can invest $800 now in an investment that compounds quarterly. What interest rate do they need to make this happen? So it says compounds quarterly. That's compounds. We know it's going to be a compound interest question, which means we use this formula A equals P times 1 plus R divided by N to the exponent NT. Now we have to figure out what we know and what we don't know. So A, we want to have 1,500 or 1,500. So A is equal to 1,500 after 5 years. So our time period is 5 years. P is equal to 800 because they now have $800 to invest. N is equal to 4 because we're compounding quarterly. That's 4 quarters in a year. And we're looking for what interest rate? So R is what we're looking for. So we substitute all of our values in for our variables that we know. So we have 1,500 is equal to 800 times 1 plus R. That's what we're looking for this time. So we leave it at R, divided by 4, all to the exponent 4 times 5. So we're going to simplify that, which we can't simplify too much because we have our variable inside of our brackets. So we have 1,500 is equal to 8,000 times 1 plus R divided by 4 to the exponent 20. So what we can do is we slowly try to isolate for R. So the first thing that we're going to do is we're going to do 1,500 divided by 800 is equal to 1 plus R divided by 4 to the exponent 20. When you're isolating for a variable, it's like you're doing BEDMAS backwards. So you're doing the order, because we're looking for the inverse, we're isolating for something. So we need to do it in reverse order. So then 1.875 is what? 1,500 divided by 800 is equal to 1 plus R divided by 4 to the exponent 20. So then because we have to the exponent 20, that is our root that we need to figure out how many times something by itself 20 times is going to get us the value that we want. So the inverse, if square root is the inverse of x squared, then the 20th root is the inverse of x to the exponent 20. So we're going to take the 20th root from both sides, which means that we have 1.0319 is equal to 1 plus R divided by 4. Remember, your nth root is your second function, most likely, of your x to the exponent y button. Are we finished? No, we still do not know what r is equal to. We've run out of space, so we're going to move over on our slide. That happens sometimes. As long as you are clear, I don't mind you having to use arrows to direct me. It's all good. I do it all the time. So in order, again, to isolate for r, we're going to now get rid of the 1 that we were adding to the 1 plus r divided by 4. So we're going to subtract both sides, 1 from both sides, which means we have 0.0319 is equals to r divided by 4. So then we're going to multiply both sides by 4 to cancel off that 4 that's dividing r. So 4 times 0.0319 is equal to 4 times r divided by 4, which means that we have 0.1277 is equal to r. So r is equal to 12.8%, right? Because our rate is given to us in a percent in our question, our interest rate. So we have to multiply that by 100 to make it a percentage. So the person would need an interest rate of 12.8% in order to earn what it is that they want to earn. So this is why you need to know that nth root, because in order to find the rate, we need to take the nth root at some point. It's a little bit awkward, but you can do it, just need to practice. All right, so again, we're going to pause and we're going to interject another situation. So here, if we have the variable in the exponent, so before we had a variable with an exponent, now we have the variable in the exponent. How do we solve for that? So here, looking at some examples, 4 to the exponent n equals 64. So this means 4 to the exponent n means that there's an n number of 4s. So 4 times 4 times 4 times 4 times 4, a certain amount of times. We don't know how many times. And that equals 64. So we don't have the tools to do this mathematically, how to figure that out. I mean, the world does, but in our course, we haven't learned that yet. That's something for another course. So we have to use the guess and check model. So we're going to try to get as close as we can. So what that means is that we do 4 to the exponent 1 is equal to 4. We know that. 4 to the exponent 2 is equal to 16. Okay, we're getting closer to 64. 4 to the exponent 3 is equal to 64. So that means that 4 to the exponent n equals 64 is the same as 4 to the exponent n equals 4 to the exponent 3, which means n is equal to 3. This is a bit of a weird one. I get it. It takes a lot more practice. This is the trickiest one in this lesson. So step 1, we use the guess and check to make the base on both sides of the equation the same. So we're trying to figure out what is going to have the same base. Then step 2 is we set the exponents equal to each other, because once we have the same base, that means that the exponents have to be equal to each other. And that's how we figure out what the exponent is. All right, let's look at another example to figure this out. So 3 to the exponent x equals 100. So our goal for the guess and check model is to get it as close to 100 as possible. Most often, we are not going to have a nice whole number like we did with the last one, 2 to the exponent, I don't even know, 4 to the exponent 3 is equal to 64. Most of the time, we're not going to have those nice round numbers. We're going to have to guess and check a lot, and you can use your calculator. That is fine. This is how you do it. You use your calculator, you get better at it, but it's okay. So we're trying to get to 100. So we're going to just start listing them off. So 3 to the exponent 3 is equal to 27. 3 to the exponent 5 is equal to 243. So now I've gone over. So I know that it has to be more than 3 to the exponent 3, and it has to be less than 3 to the exponent 5. So 3 to the exponent 4 is 81. Okay, so I know that has to be bigger than 3 to the exponent 4. So now I have to start using decimals, which is why I have to use guess and check, because we're guessing to try to get as close as we can. So 3 to the exponent 4.5 is equal to 140.3. And again, I'm using my calculator. I'm going in my calculator and I'm putting in 3 to the exponent 4.5. Am I close enough? No. Okay. I have to be smaller. So 3 to the exponent 4.1 equals 90.4. Okay, I'm getting closer. I'm getting sort of bound. So I kind of go too high and then I guess lower and then I go, okay, that's too low. And then I guess something like I'm bouncing back and forth to try to narrow in on getting as close to 100 as possible. So 3 to the exponent 4.2 is 100.9. That's pretty close. So I'm going to say that that's close enough. If you wanted to continue to narrow it down, okay, but that's pretty close and we don't need to spending hours figuring out the exponents. So 3 to the exponent x is approximately 3 to the exponent 4.2. So x is equal to 4.2. So if you were to put in your calculator 3 to the exponent 4.2, you're going to get an answer that is really close to 100. So let's keep trying another example. So what if I have 2 is equal to 1.0275 to the exponent n? What does this mean? So our goal is to get as close to 2 as possible. We are looking for this value. That is what we're trying to get as close to, right? Equal whatever we're trying to equal. So we're trying to equal as close to 2 as possible. So we're going to put it into our calculator, and sometimes you're going to be way off. So we start off with 1.0275 is our number to the exponent 2 is equal to 1.0558. So I'm not close to 2 at all. So then I'm just going to keep trying. I'm going to jump. So 275 to the exponent 5 is equal to 1.1453. So still not very close at all. So I'm going to take a bigger jump to try to get me closer. So 1.0275 to the exponent 20 is equal to 1.7204. So closer, a lot closer, but still pretty far away. So 1.0275 to the exponent 25, I get 1.9704. Okay, definitely getting closer to 2. 1.0275 to the exponent 26 is equal to 2.0245. So if I wanted to, I can go back a little bit smaller and go 1.0275 to the exponent 25.5 is equal to 1.9973. So I'm going to say that that's close enough for me. So 1.0275 to the exponent 25.5 is equal to 1.0275 to the exponent n. So therefore 24.5 is equal to n. So this is all kind of weird and we're going to be using it, but you're going to have to practice this. This is tricky. If you need to go back and practice this a few times, we're going to be using this in the context of our questions, but you're going to need to know how to do this skill. All right, so we're looking at time length. That's what we're finding next. And if you're in your IL booklet is old and you are finding the n, then you need to be using the guess and check model, which is even a little bit different than what we're going to be doing here because it's broken. Ours is broken up a little bit more. So just be patient with yourself, but you have to be using guess and check. This is on page 17 in your IL booklet. And if you have a newer one that was updated in 2021, then you should be similar to what I'm doing on the screen today. So finding the time length, T, in compound interest is what we're looking at now. So the real life context is when you want to find how long you need to invest in order to earn a certain amount. So let's look at our example. A company invests $25,000 that will pay 8.25% compounded monthly. How long will they have to leave the investment for it to double? So it says compounded monthly. We know that we're using compound interest formula. And we need to figure out what we know and what we don't know. So the company invests $25,000. So that means that our principal, we're starting with $25,000. Our rate, because it pays 8.25%, is a 0.0825. We're compounding monthly, which means that n is equal to 12 because it's monthly. And we want it to double. So this is tricky because this is our final amount. We want it to double. They don't give us the number explicitly, but they tell us we want it to double. So double of to 25,000 is 50,000. So how long will they leave it? They're going to leave it, that's what we're looking for. We're trying to figure out what our time is. So now that we know all of our variables, we're going to substitute them in. So we have 50,000 is equal to 25,000 times 1 plus 0.0825 divided by 12, all exponent 12 times t. So we're going to simplify what we can. So we're going to do 50,000 divided by 25,000 is equal to 1 plus 0.006875 to the exponent 12t. So that means we have 2 is equal to 1.006875 to the exponent 12t. So this should look really familiar in terms of what we just practiced. We have to guess and check in order to figure out our number as close to 2 as possible. So we're going to put in our base 1.006875, and I picked 10 to just start with to give me a starting point. And that equals 1.0709. So not close to 2, really. So I'm going to pick a bigger number. 1.006875 to the exponent 20, and that got 1.1369. So again, not very big. 1.006875 to the exponent 50 equals 1.4087. Getting bigger, but still we have a long ways to go in order to get as close to 2 as possible. So I'm still going to keep jumping. 1.006875 to the exponent 100 equals 1.9841. The values that I'm picking for my exponents, I'm just picking at random in terms of friendly numbers that I'm going to put in my calculator. So there's not a perfect numbers to pick. So I'm definitely closer to 2. How much closer can I get? 1.006875 to the exponent 110 equals 2.1248. So I've gone over. I know my limit, my top. 1.006875 to the exponent 105 is equal to 2.0532. So still too high. 1.006875 to the exponent 101 equals 1.9977. So that's close enough for me. So 1.006875 to the exponent 101 is approximately equal to 1.006875 to the exponent 12t. So that means that 101 is equal to 12t, which means we need to isolate for t. So we divide both sides by 12, which means that t is equal to 8.4. So what does that even mean? So therefore, the company needs to invest for 8.4 years in order to double their investment. So this one's tricky, definitely. It's different than everything else we're doing. You can do it, you just need to have some patience. All right, so now you can do the support questions on page 18, questions 1 through 4. All right, we have a few minutes to do some practice questions, so let's do a couple. All right, number 1, Jiva is 10 years old. His parents have decided to invest some money for his future, so that he will have $15,000 at age 18 when he finishes high school. If the investment can earn 6.6% compounded monthly, how much will his parents need to invest? So we have to go through and figure out what we know, what we don't know. First, this question says compounds. So because it says compounds, we know that we're using the compound interest formula. So we know that we're using A equals P times 1 plus R divided by N, exponent NT. Remember, you can look this up if you need to. That's fine. So now I'm going to list off all of my variables to see what I know and what I don't know. All right. So then I'm going to go through my question and fill out what it is. Instead of looking for the variables, I'm going to say, okay. So Jiva is 10 years old. His parents have decided to invest money for his future. So they will have $15,000 at age 18. So we want $15,000 is our amount that we want. We wanted at age 18. Do we have 18 years to do this? No, because he's already 10 years old. So we have 18, take away 10. So we have 8 years. So T is equal to 8. The investment can earn 6.6% compounded monthly. So that means that our rate is 6.6%. which is equal to 0.066, and compounded monthly is 12, so n is equal to 12. Then how much will his parents need to invest is our principal, and that's what we're left with not knowing. So then we put in the numbers that we know. So 15,000 is equal to P times 1 plus 0.066 divided by 12 to the exponent 12 times 8. So then how I like to do these things is I'm just going to do it all in one step because I'm going to do it on my Desmos calculator because that's what makes me happy. You can do it, whatever makes you happy, but I'm going to not do any of my parts. I'm going to do it all at once on my Desmos calculator. So I'm going to put 15,000 divided by, open a bracket, 1 plus 0.066 divided by 12, close my bracket. Oops. To the exponent, remember, open my bracket, 12 times 8 is equal to $8,859.56. 88.59.56. So we make sure that we've answered the question by writing a sentence. Jiva, sorry. His parents need to invest $8,859.56. There we go. All right, number 2. Everett at 18 is planning for his future. He has $1,000 and wonders what interest rate, compounded semi-annually, he would need to have $1 million when he retires at 65. So compounded semi-annually tells us that we're using our compound interest question. So our formula, A equals P times 1 plus R divided by N to the exponent NT. So Everett at 18 is planning for his future. He has $1,000. Okay, so our principal is $1,000 and wonders what interest rate. Okay, so it says what interest rate we're looking for. Compounded semi-annually, so that's 2 times a year. He would need to have $1 million. So the final amount that we have is $1 million. Make sure you get enough zeros. When he retires at 65. So does he have 65 years? No, we have to do 65 take away 18. So if it was 65 take away 20, then that would be 45 years, but it's 65 take away 18, so 20 is 2 years more, so that means it's 47 years. Okay, so we put in what we know and what we're looking for. So 1 million is equal to 1,000 times 1 plus R we're looking for over 2 to the exponent 2 times 47. So this time I can't do as much on my calculator as I would like in one go. So I'm going to do 1 million divided by 1,000 is equal to 1 plus R divided by 2 to exponent 2 times 47. Well, 2 times 45 is 90. So 2 times 47 is going to be 94. So I know that 1 million divided by 1,000 is 1,000 is equal to 1 plus R divided by 2 to exponent 94. Well, if I want to, this is my exponent, I need to take my nth root, my 94th root, in order to do the opposite to get rid of that, right? So if I do it on one side, I have to do it on the other side. So now I have to use my calculator because I don't know the 95th fourth root on my own. And now I'm going to end up having a decimal because it's not going to be a happy number. So 1.07625 is equal to 1 plus R divided by 2. So now if I subtract 1 from both sides to continue to isolate for R. We get 0.07625 is equal to R divided by 2. So I'm going to multiply both sides by 2 in order to cancel the 2 off. And that I'm going to do on my calculator. I'm going to do 2 times 0.07625. Really doesn't want to let me do. Okay. Is 0.1525 is equal to R. So therefore, Everett would need a rate of, and we're going to have to do 15.25%, right? We put it in a percentage. So you can do that. R is equal to 15.25%. That's what we use it for. Okay, so we're not going to have time to do this last practice problem where we are figuring out our time length. This is the guess and check one, and it takes a while. So go back over that section if you need more practice. If you want more practice with this, give me a call. We can do some more practice individually if we need to. Okay, so let's consolidate. Let's do an overview of what we've done today. So for lesson 8, which is compound interest formula, we have dissected the compound interest problem. So we figured out what that compound must be in the problem in order for it to use this formula. Then we must identify what information is given and what information we're being asked to find. It's essential. Then when we're finding the principal, we need to rearrange our formula to using algebra to isolate for P. We're finding an interest rate, R. We need to use the nth root to isolate R. And then we're finding the time length, T. We need to use guess and check to force the bases to be the same. Then the exponents can be set as equal in order to isolate for T. So these are a little bit tricky things. They take some practice. If you need practice, you need to check in with me to work it through it, please reach out. So hopefully you can identify the given and missing information in the compound interest problems. You can use the nth root and guess and check methods to solve problems using exponents. Those are the tricky ones. And you can solve problems when either the interest rate or time length are missing. All right, so as always, if you have any questions, please reach out and connect with me. I'm here to support. These things are awkward. I get it. I know that they're tricky, and that's why we're here, to learn together. So please reach out and contact me if you'd like some support. You can call me at the office at 807-737-1488, extension 2209. You can also reach out toll free at 1-800-667-3703. You can email me at bronwyn.slate, that's spelled BRONWYN.SLATE@nnec.on.ca. You can also connect with me through Facebook, where my name is B Slate Wahsa. Remember that this lesson and all of our other lessons will be on YouTube on my channel, B Slate Wahsa, under the playlist MBF3C. You want to connect with me directly? My office hours are Monday through Friday, 9 a.m. to 3 p.m. Though on Thursdays, it's actually from 10:15 to 4:15. It's a little bit of shift that day. But please reach out and I can always get back to you and we can figure out a time that works for both of us. Thank you so much for joining me today. I hope you have a lovely day. Which